So at this point in our systems of equations unit, we are on our last solving method, which is the elimination method. Up to now we've done graphing and substitution, so this will be the last one we see. And we're also going to start looking at how certain equations and problems that we face lend themselves more to one type of method than another. So in class today, we had done some word problems, and we ended up with some equations that looked like this. And we solved them the long way using substitution, but actually today we're going to see how we could have solved them much quicker using elimination. So for elimination, just like substitution, there's 5 steps that we are going to follow. So if you want to pause your video right now, you can copy these down. There's 1 through 3. And you can pause it for 4 and 5 as well. Okay, so I'm going to refer to these steps as I go through some problems. First problem we're going to look at actually comes directly from the work we did today. Number 1 on our word problems, we ended up with the 2 equations 6x plus 8y equals 42 and 3x plus 8y equals 33. So I rewrote those equations. You should be rewriting them as well. And our step 1 says line up variables and constants in both equations. So what that means is I want my x's in line, one above the other, y's are in line, and then on the other side, the equal sign, I have my constants. So this is already lined up for me. The next thing I'm going to do is find the variables that have the same coefficient, and we know that coefficient is a fancy name for the number in front of a variable. So my coefficient here is 6 and this is 3, so my x's do not have the same coefficient. When I jump over to my y's, I see that there's an 8 in front of both. So that would be the coefficient that's the same, and that's what we're looking for. Number 3 tells me that I should cancel out that variable by adding or subtracting equations. So we have to think now, how do we decide whether we're adding or subtracting? It's based on what the sign is of that coefficient that's the same. These are both positive 8s. So if I wanted to get rid of them, I would have to subtract them, because 8, a positive 8, minus a positive 8 leaves me with 0, y. So that's eliminating them. What I'm going to do is make a big subtraction problem. I've decided it's subtraction, so I'm subtracting the equations from each other now. So I'll start with my x's. I have 6x minus 3x leaves me with 3x. I have 8y minus 8y, which leaves me with 0y. So I could write 0y down, but if I have no y's or 0 y's left, I'm not even going to write that. I'm just going to cancel them out. And then I still have to think about this side. I have 42 minus 33, which is 9. So I have 3x equals 9 at this point. Step 4 tells me I should solve for the remaining variable. So I have x left, and I'm going to solve for x. 3x equals 9. I would divide by 3 on both sides to get x by itself. I'm left with x equals 3. That was pretty quick. Finally, step 5, very similar to our substitution method, is substituting back in. So we're going to substitute the answer I just got, x equals 3, into one of the original equations to solve for the eliminated variable. So I'm going to go back to my original equations. It doesn't matter which one I choose. I'm going to pick the first one just because it's first, and I'm going to substitute x back in for x up there. So I have 6 times x, which is 3, plus 8y equals 42. Think of DCS, distribute, combine, solve. So distribute 6 times 3 is 18, plus 8y equals 42. two-step equation. To get y by itself, I have to subtract 18. I'm left with 8y equals 24. Final step, divide by 8. Y equals 3. And that was the answer that we got in class today for this problem. We ended up finding out that the small row contains 3 muffins and the large one contains 3 as well. So that was the answer we got in class. This is a much shorter set of steps than what we did in class by substitution, and we got rid of the dealing with fractions and decimals that we don't like very much. Okay, so I'm going to give you another problem now, still part of your summary here. And in this problem, if I could find it, here it is. In this problem, what's going to look different is the way that we eliminate. Okay, so step 1, line up the variables. They're lined up. Here's my x's, here's my y's, here's my constants on the other side. I'm going to find the variables that have the same coefficient. So we're looking for just the number in front. Here's a 5 and here's a 5. I'm ignoring that negative sign for a second. They're both the value of 5. Those are the same. 4 and we know that's a 1 are not the same, so that's not what I'm looking at. I'm looking at the x's this time. I'm going to decide whether I'm adding or subtracting. Okay, that's step 3, and we're going to cancel. Now I'm looking at the signs. If this is a positive 5 and this is a negative 5, to get them to cancel out, I would have to add them together, because a positive plus a negative of the same number equals 0. So I'm adding both of these equations now. 5 plus a negative 5 is nothing, so those would be the ones that cancel out. 4 plus 1y is 5y. And then 20 plus 30 is 50. So this one was solved a little bit differently because our coefficients had opposite signs. In the last one, we subtracted because they were the same sign. Different signs, we're going to add them together. So last step here, I have y equals 10. That part's done. Step 4 tells me to solve for the remaining variable, so that means I have to plug y equals 10 into one of my equations. Again, it really doesn't matter which one you choose. I'm just going to pick this one since it's already 1y, so I'm just plugging 10 in. So I have negative 5x plus 1y, which is 10, equals 30. Subtract 10 on both sides. And I'm left with negative 5x equals 20. And dividing by a negative 5, don't forget that it's a negative 5. A lot of times we're just dividing by 5, but it's still negative. And those cancel out to x equals 20 divided by a negative 5 is a negative 4. So my answer here would be negative 4, 10. Okay, and this one didn't come with a word problem, so I am going to write it as an ordered pair. Whereas in the other one, correlating to our work from today, we had a word answer with it. So this one would be negative 4 is my x, 10 is my y, ordered pair answer. Okay. All right, for our last example, I switched things a little bit. Step 1 tells me to make sure that my variables are lined up in my two equations. Here they're not. I have x with y, y with x. So all I'm going to simply do is switch the order of one of the equations so that they are lined up. Now remember, I can switch things around a plus sign and it won't change the value. If these were numbers, if I had 4 and 2, 4 plus 2 is the same as 2 plus 4. So changing the order doesn't matter. Now if I had subtraction signs here, I would change it to plus and negative, and we will see some of those tomorrow. And that way we're only dealing with addition. So I'm going to rewrite this first equation to switch my y and x, and then just write it below here. So 3y I want to be in front, and I'm going to put the 2x after it, and it still equals 18 at this point. Nothing has changed there. So I'm scratching out that first equation so I don't get confused. They're lined up. Y's don't have the same coefficient, but my x's do. So that's what I'm canceling. They're both positive, so when they're both positive, the only way to cancel out to 0 is to subtract. So I'm subtracting my two equations. I have 1y minus 3y, or plus a negative 3y, is negative 2y. 2x minus 2x is nothing, and that equals 2 minus 18, which is the same as plus a negative 18, gives me negative 16. Divide by negative 2, and I'm left with y equals 8. Okay? I have to plug that back in to solve for x. I'm going to use my first equation here, 1y plus 2x equals 2. So I have 1y, which is 8, plus 2x equals 2. Subtract 8 on both sides. I have 2x equals, that's 2 plus a negative 8, negative 6, divide by 2, divide by 2. So once I divide, I'm left with x equals negative 3. And again, we didn't have a word problem here, so I'm going to write my answer as an ordered pair. And that would be the solution set to this system of equations. All right, your job for tonight is to go back to the work we did today. And number 2 in our word problems also lends itself to elimination pretty easily based on the variable coefficients we're given. So I want you to resolve number 2. I know we already have the answer and we've checked it, but I want you to resolve it using elimination so you could see how much less time and how much easier the numbers are to work with when we're dealing with elimination in this case. Also, what I want you to do is go through the examples that I gave you on the video today and plug them back in to make sure that they actually work in both equations. We always check our work. And that'll be it. So tomorrow when you come in, be ready with those things, and we're going to put this to use. Have a good night.